Hello people, this is Pradeep Vibhuti. Now we shall see field effector transistor FET. So it is one of the devices like BJT. BJT is a current control device and FET is a voltage control device. So here is the construction. So it is made up of N type as well as P type, but P layer, okay, they are two and one N type layer. So you can observe that drain, a wire is connected through something like as soldering to this material. You can call it as ohmic contacts to one side of the drain, that is one side of n type, and another side of n type is connected to the source, and gate is connected to the p type. So this is the construction, and you can notice here that there is a depletion region, okay, developed on its own when you connect to n type and p type material. So what is depletion region? You must know it. Okay, just in a brief, let me explain what is depletion region. Whenever you connect an n type material and okay p type material, what happens whenever you join them? Actually it is joined, okay, there is an layer connected in between these two. There is a layer creation between these two is something like this, because n type will be having, okay, holes as charge carriers and p type will be having electrons as charge carriers. So due to the attraction between holes, okay, there is a layer creation, that is voltage creation here. It is something like a dielectric material, okay, and potential is created here. So once that is breakdown, then only the current will start to flow here between these two. This is what is there in BJT, but here it will not break down. Here we are not intending it to break it down, but in diode and BJT we are intending it to break it down. That was a brief explanation about depletion region. Now why it is called as drain, gate and source, we will see. It is same as water analogy. Okay, source is coming from the pipe and drain is the place where it will collect all the wastewater and move it out. And here we have a knob which is called as gate, which will control the flow of this water. So similarly, source is this, because from here electrons will start to flow. Okay, electrons will start to flow from here in this direction and it will go to the drain. So if electrons goes in this direction, then current is in this direction. We all know it, correct? Current direction is always opposite to the electron direction. Fine. So this is why the name came with the source, drain and gate for FET. So further we'll analyze how and what will happen when we actually connect some potential difference between gate and source. So in this example, we are not connecting any voltage source between gate and source. That is, we are circuiting it. That is, we are short circuiting it with gate and source, so that this potential 0 is here. So VGS is 0. During this time, what happens? Okay, actually electrons will start to flow because there is an VDD. So between drain to source, VDS, here we have given some voltage which is greater than 0. Okay, there is nothing new here. Okay, we just have connected 0. So for this 0 potential, that is, this is 0, right, and this is some potential. So because of that, electrons will be pulled from this end to this end because this is positive, and since this is negative, electrons will be repelled. So electrons will go in this direction and current will flow in this direction. And note that id is same as is because it is in series. Okay, there is no parallel path here or division here for the current. Now here, whenever the current is flowing, obviously there will be some opposition because it is made up of some material. Every material will have its own resistance. So whenever there is a resistance, there is an voltage drop. Current into resistance is nothing but Ohm's law, which is voltage drop. So we'll assume that this is zero potential because source was given to the ground. Okay, please note that source is given to the ground and the drain is given to the some supply. So if you give 2 volts, what will happen? It will be equally distributed. 0.5 plus 1, that is 0.5 plus 0.5 is 1, 1 plus 0.5 is 1.5, 1.5 plus 0.5 is 2 volts. It is equally distributed because the material is construction is like that, and you are not giving any gate current here, so you will have some current, correct? So that current is this. So why here it is linear and why here it is saturation, you will see. So here it is linear because resistance is a linear element, so current will also be increasing from 0 volts to 2 volts. So from 0 to, suppose this is VDS is 2 volts here, so from there, so from 0 to 2 it will go linearly. And at 2 volts, what is happening is, okay, at this point a time will come where these two depletion region, what you can see here, yes, here it was like this, now it has become like this, it has been enlarged. Okay, why it has been enlarged, we will try to understand. So if a depletion region is enlarged, the channel or the path, we call it as a channel, okay, that channel area is reduced. You can see here it is reduced. So once it is reduced, resistance increases, okay, and slowly current decreases. But ideally what should happen, whenever, okay, you can see here, for some voltage, we will not take this as VGS is equal to 0, okay, for some voltage you assume that it is been, okay, touching these two depletion region touches, and that point we call it as pinch off. It is just something like okay, bringing two fingers together, right? This is one finger, this is thumb, this is forefinger, and you are pinching it. So there is no path for the current. Ideally there is no path for the current here, but practically there will be some small amount of current, just like leakage current. There will be a small opening here, so that will allow the constant current to flow. So hope you understood why this is straight line and why this is linear. This is linear because it is ohmic. Okay, resistance is in linear element, so current will also vary linearly. So something like V is equal to IR. R is a linear element, some constant. So as V increases, I also increases. So V is increasing from 0 to 2. So I is also increasing from 0 to some value in milliampere only. Okay, so this is N channel resistance, and this is due to narrow channel. As I said, channel will become narrower and narrower. So at some point it will pinch off. At some value of current it will pinch off. Now what will happen if we give a negative voltage here, is the case shown here. See, positive is connected here to the source. So here what is majority carriers? See, in N type, majority carriers are electrons and minority carriers are holes. In P type, majority are holes and minority are electrons. So here please concentrate. Holes, okay, this is electron and this is a hole. Hole, we call it as, if there is no electron, means hole is created. It is an atom. So atom will never move, only electrons will move. Atom will be there only, right? So because of that, P, this is hole, and this is electron. As I said, hole will not move, so electrons from here will move here. So if you remove all the electrons here, okay, what will happen? Current will not go here, right? Yes. So if you remove less electrons, less current will go here. If you remove more electrons, how will you remove? You increase the voltage. Okay, it means you are extracting most of the electrons here, because this is positive plate, right? Positive plate will attract the electrons, negative charges, so it will come here. So electrons will come here, so this electron will not go here. Means if this is not going, what will happen? Obviously id will reduce. Did you get it? And why depletion region goes on increases as you remove electrons? Okay, see, this is positive and this is negative. There is a potential difference, and as you remove electrons, this depletion region goes on increases. Okay, that we can see here in this graph. In this graph, that is what is explained. Okay, so we'll understand these two simultaneously. See, as I said, for VGS some current will be flowing, and that current we call it as IDSS. We call it as, you can remember it as steady state drain current, IDSS, or you can also remember it as saturation. But saturation is there for every VGS. Here VGS was 0, so this was the graph. Now what you do, VGS is reduced. Reduced means what? You have applied -1 volt. -1 volt is less than 0. Okay, so it will also have some saturation current, and in ohmic region a small current will be there. So linearly it will vary. After it reaches that some point, pinch off voltage will be attained. Once electrons are removed from here, obviously this will come in contact. Okay, so sufficient electrons are removed by having a current. Once that happens, they come in contact. So similarly, you increase the voltage, what will happen? More electrons you have removed. More electrons you have removed means the n channel has become narrower, because channel is created due to this n type, right? N type is what? Majority carriers is electrons. Once majority electrons you have removed, no electrons left out, so no current will go. So similarly, you have still increased it to 3 volts. Once you still increase it to 3 volts, still it will come narrower. Once you still increase it to 4 volts, okay, what happens? They come in contact. So you call it as pinch off voltage. That is, VGS is equal to -4 is pinch off voltage. At that time you can see there is no ID, there is no drain current. Even though the VDS is increased, there is no drain current. So that is this condition. So pinch off voltage is there for every VGS. For every VGS, pinch off voltage varies. See here, for this VGS, this is the pinch off voltage. For this VGS -1, this is the pinch off voltage. For this VGS -2, this is the pinch off voltage. So this is the locus of pinch off voltage, pinch off value. So we have understood this. So we'll summarize it here. So this is the transfer curve. What is transfer curve? Okay, this is input VGS you are varying. What is happening with the VDS? See, what is the input here? Input is you have control over it, right? So this is your controlling parameter. What is the output parameter? VDS is varying, correct? So that graph is been plotted here. So this is the output graph actually, VDS. So this is the output side. Input side is gate, output side is VDS. So input side, what you are doing, when VGS was 0, you had got some IDSS. Okay, you plotted on this graph. And similarly, when VGS was -1, this was the IDSS you got from this graph, correct? And here, when VGS was -2, IDSS was here. When VGS was -3, IDSS was here. -4, IDSS is here. So -1 IDSS, -2 IDSS, -3 this is the IDSS, and -4 IDSS is 0. So once you get this, you complete the points with a freehand drawing, you'll get this graph, and this already we have seen. So this is the input output relationship. That's why we call it as transfer. Transferring means what amount of value is transferred from input to output. So hope you have got some idea about this. Okay, I have tried to explain within a shorter time. Okay, but you analyze on your own. Okay, once again go through this. You can pause the video, analyze on your own, recall the things. Okay, try to perceive the things on your own with your intellect, and then it will be easy to understand. That's it from the basic point of view. Now in next video we will see the biasing effect, that is the biasing of FETs, self biasing, okay, voltage divider biasing, and so on. Thank you.